Not all atoms of elements are absolutely identical to each other. Of course, the number of protons is the same. And if the atom is neutral, the number of electrons is equal to the number of protons. But the number of neutrons can vary, and this gives rise to something that we call isotopes. So what we're going to do in this lecture is look at isotopes and what arises from those, the mass number. And we're also going to look at the terms atomic number and atomic mass. All right, we have seen that atoms are made of electrons, protons, and neutrons, and we know that the number of protons identifies what element we have. In a neutral atom, the number of electrons is equal to the number of protons, but we can modify the number of electrons by taking away or adding electrons, and we've seen that this makes charge. If we add electrons, it makes a negative charge, and if we take away electrons, it makes a positive charge. But what about these neutrons? Neutron numbers can vary. The number of protons determines the atom, but the number of neutrons has nothing to do with the identity of the atom. Some carbon atoms can have 5 neutrons, some can have 6, some can have 7, and some can have 8. They're all carbon with 6 protons and 6 electrons when it's neutral, but the number of neutrons can vary up and down, but it's all still carbon. The only thing that changes about that atom is its mass and its nuclear stability, which we're not going to worry about right now. So the mass changes as you go from carbon with 5 neutrons to 6 neutrons to 7 neutrons and 8 neutrons. If you remember, 6 protons in carbon, 5 neutrons, well, that will have a mass of 11 AMU because both protons and neutrons each have a mass of 1 AMU. If you have 6 protons and 6 neutrons, well, that's 12 AMU. 6 protons and 7 neutrons, that's a carbon atom with 13 AMU. And 6 protons and 8 neutrons is a carbon atom with 14 AMU. All of them are still carbon. We call these different atoms of carbon isotopes. Isotopes are atoms of the same element with a different mass, or you can call them atoms of the same element with different numbers of neutrons. The isotopes of hydrogen demonstrate this quite well. There are 3 common isotopes of hydrogen. 2 of them occur naturally here on Earth, hydrogen and deuterium. Tritium, we synthesize this in nuclear reactions, for instance, in nuclear reactors or at some of these high energy particle colliders that they have. Hydrogen, the hydrogen isotope, has just 1 proton and 1 electron. Notice there are no neutrons. The deuterium isotope has a proton and a neutron and 1 electron, of course, to remain neutral. The mass of this isotope is 1 AMU. The mass of this isotope is 2 AMU. Tritium has 2 neutrons and 1 proton. It's still hydrogen because there's 1 proton, but now it has a mass of 3 AMU in the nucleus. The isotopes of hydrogen are the only isotopes that have specific names like deuterium and tritium. The remaining isotopes are identified in a different way. We use isotopic notation to identify these different isotopes. Okay, well, let's look at isotopic notation for this isotope of phosphorus. Phosphorus, if you look on the periodic table, you will see that the atomic number is 15. The atomic number is given the symbol Z. Z means Z equals the number of protons. So Z equal 15 means there are 15 protons. That's redundant with the symbol, because I can look on the periodic table and see the atomic number is 15. If I write P for phosphorus, I know that atom must have 15 protons in it. So this number is rather redundant, and sometimes we'll leave this off in discussing isotopes. This number up here, as a superscript, is called the mass number and is given the symbol A. This mass number is the number of particles having mass. The particles having mass are neutrons and protons. So in this atom here, I know there are 15 protons. Looking at this number, if I take 15 protons out of this, then there are 18 neutrons left behind. This isotope is called phosphorus 33, and in text we just write isotopes out like this without using isotopic notation. So you'll see isotopes referred to in text this way. This isotopic notation is very easy, but many people do get confused using isotopic notation, and it requires some practice to get this right. Be aware that this number right here, the superscript in isotopic notation, does not come from the periodic table. People are tempted to try and get isotopic notation from the periodic table, and there are no isotopes in a typical periodic table. Isotopes are atoms that are found in nature and have a specific mass due to a specific number of neutrons, and we don't list them in our periodic table. If I'm going to use isotopic notation for the isotopes of hydrogen, you can see because hydrogen has only one proton and no neutrons, the atomic number of hydrogen must be 1 because it is hydrogen, and all hydrogen atoms have one proton. There are no neutrons, so the mass number is only 1. Because deuterium has one proton and one neutron, the mass number is those two numbers added together, 1 plus 1, giving us 2. And because deuterium has 2 neutrons and 1 proton, its mass number is 3. Now what I would like you to do is to pause this lecture and do these problems and then check your answers in the following slides.
The first thing that you recognize when doing this problem is that you see it says 12 protons. So right off the bat you know 12 protons is magnesium, so you write the magnesium symbol. Next you look and you see that you have 10 neutrons. From 10 neutrons you know that the mass of the atom is the number of neutrons plus the number of protons, so you add the number of protons and neutrons together and get 22. Then you want to put your charge on there, and you see there are 12 protons and 11 electrons. That means there's one less electron, which means more positives than negatives. One positive charge. In order to put the atomic number on there, we look at the number of protons. However, this is redundant with the symbol magnesium, so many times you'll see it left off. How many protons, neutrons, and electrons are in chlorine 37 with a 2 positive charge? The first thing I notice is that it's chlorine, so I know right off the bat there's 17 protons. Then from the mass number 37, I know that if I take 17 out of 37, I have 20 left, so that must be how many neutrons I have. The number of electrons can be figured from the charge. 17 protons with a 2 positive charge means there's 2 fewer electrons than there are protons, so there are 15 electrons. To do this problem, right off the bat, I know that there are 29 protons because this is copper, and the atomic number for copper is 29. I then can look at 65 the mass number and subtract out the number of protons. That gives me 65 neutrons and protons minus 29 protons. I have 36 neutrons. The charge of -1 on copper means there's one more electron than there are protons, so in total there must be 30 electrons. Now, these terms, atomic number, mass number, and atomic mass, are very easy to confuse. They're very similar and so easy to confuse. Notice that both atomic number and mass number have the word number in them, and they're talking about numbers of particles. Atomic number is the number of protons, and the mass number is the number of particles with mass, neutrons and protons. Remember, electrons have almost no mass, so we don't have to consider them in the mass of an atom when we're just looking at isotopic notation. The atomic mass of an element, however, is different from the atomic number and the mass number. The atomic mass is the average mass of all atoms of that particular element. So this would be all the common isotopes. However, isotopic proportions or abundance varies as you go from element to element. Some elements might have 1 or 2 natural isotopes, and others might have 6 or 7. It all depends on how the stability of the nucleus plays out. As a result, we have an average mass of all the atoms of a particular element, but it depends on the isotopic abundance. And so the atomic mass is the average mass of all atoms of that element, depending on their mass and abundance. One thing to notice before we go on is that the number in the periodic table that is the atomic mass is the number that has a decimal. So the atomic mass of nitrogen is 14.01. The atomic mass of chlorine is 35.45. Those are the average masses of atoms of those elements as we find here on Earth.
Atomic mass is the number you find on the periodic table that has a decimal. When we look at atoms, we don't find any one atom that will have the mass of the atomic mass unless it's just by chance. The atomic mass that is given on the periodic table is the average mass of an atom based on the abundance of its isotope. For instance, with hydrogen, more than 99% of the hydrogen atoms are hydrogen 1. Very few of them are hydrogen 2 or deuterium, and hydrogen 3, tritium, is not found naturally in nature. Because the majority of the hydrogen isotopes is hydrogen with a mass of 1 AMU, the average mass of the hydrogen isotopes is very close to 1 AMU, but slightly above due to some deuterium being there. So this is an average mass of hydrogen based on the abundance of its isotopes. Just as the average number of children in an American family is 1.6, but no family has 1.6 children, the atomic mass is the average mass of the atoms of a particular element, but no atom of that element weighs that atomic mass. So now what I would like you to do is to pause the lecture and do the problems here to make sure you understand the terminology and the concepts that we just covered, and then press resume when you're finished doing these problems. What is the mass number of chlorine 37 with a 2+ charge? The mass number is this number up here that's given the symbol A. So the mass number is 37. what is the atomic number of copper 65 with a 1 minus charge? Copper has 29 protons. So 29 protons is the atomic number of copper. What is the atomic mass of copper? The atomic mass is the average mass of all copper atoms. If I look at the periodic table, I will see that it is 63.546 AMU. Notice, atomic mass has a unit on it because we're not counting particles like we do for mass number or atomic number. So it must have units on it. There are only two isotopes of chlorine, chlorine 35 and chlorine 37, which is more abundant. If I look at the periodic table, I will see that the atomic mass of chlorine is 35.453. That means the average mass of all chlorine atoms is closer to 35 than to 37. That means chlorine 35 is most abundant. There is less of chlorine 37. So, knowing what the isotopes of fluorine are, 17, 18, 19, 20, 21, and 22, which do you suppose is most abundant? If you look at the periodic table, you will see that the atomic mass is about 19 AMU. It is not exactly 19 AMU, but very close to it. Well, most likely, the most abundant isotope is then close to that. So, you can guess that fluorine, since it has an atomic mass of about 19 AMU, most likely has the most abundant isotope of fluorine 19. Can you ever have an isotope of rubidium with a mass number of 85.47? No, you cannot. 85.47 is the average mass of all rubidium atoms, and it has nothing to do with any particular atom. It's the average of all those atoms.